I am Professor Pratap N. Shinde. Welcome you all for the lecture of engineering mechanics. Before proceeding towards today's lecture, let's recap what we have learned in last few lectures. In last lecture, we have learned the definition of moment. What is the moment? Moment is nothing but the force into perpendicular distance. A rotation effect produced by the moment. So there are the two types of moment we have considered. One is the clockwise sense and another one is the moment is in anti-clockwise sense. We have assumed anti-clockwise moment is positive and clockwise moment we have assumed the sign convention of clockwise moment is negative. After that we have learned the definition of couple. So what is couple? Two equal and opposite forces produce the couple. A turning effect produced by the forces is known as a couple. The couple is produced only by the two equal and opposite forces which is separated by the lever arm. So this is couple. Then after that we have learned the theorem of Varignon. So in that theorem we have learned the usefulness of that theorem. The theorem is generally useful for the calculation of position of resultant with respect to some reference point. So Varignon's theorem is applicable to find out the position of resultant. So let's today we are going to solve some simple numericals. So first, in order to understand the concept of moment, we will proceed towards one numerical which is based on the parallel forces. Parallel force means the distance between the two forces remains constant. Okay. So the statement of the problem is find the resultant R and moment of all the forces about point A. So here in this problem there are different forces are given. The force is acting at point A is 250 Newton vertically downward. The second force is 500 Newton at point C vertically upward. 350 Newton at point D vertically downward, and the force 150 Newton at point D vertically upward, and force 200 Newton which is acting at point B which is again vertically upward. Now this is system of forces given. So first we have to find out the resultant. What is resultant? We have to replace the system of forces by a single force which will produce the same effect as that of the system of forces. So we know that in order to find out the resultant, we must know the summation of f of x and the summation of f of y. That is nothing but the summation of all the forces in x direction first we have to find out, and summation of all the forces in y direction also we have to find out. So if you observe this figure, so in this figure there is no force in x direction. All the forces are in y direction. It is all the forces are acting in vertically upward direction or either in a downward direction. So to find out the resultant, summation of f of x is equal to, can we write down directly 0? Yes, we can, because there is no force in a x direction. Then again we have to find out the summation of f of y. What is summation of f of y? Summation of all the forces in y direction. While writing the equation of summation of f of y, you must have to take care of sign. So we have assumed the forces which are going in upward direction is positive and the forces which are going in a downward directions are negative. So let's begin with the first force, 250 Newton. So this 250 Newton force is in vertically downward direction, therefore I have written it is a minus 250 Newton. Then add the force 500 Newton, so it is vertically upward, therefore I have written over here plus 500 Newton. Then third force 350 Newton, it is again in downward direction, so it must be a minus. So minus 350 Newton. Again the force is 150 Newton vertically upward, so it is plus 150. And another force 200 Newton which is acting at B, it is vertically upward, so we have to write it is plus 200. So after adding this, you will get one answer. So the answer comes out to be plus 250. So it indicates that your resultant is, or your summation of f of y is 250 Newton. Okay. Now resultant is known to us. Now next summation of f of x and f of y is known to us. Then next step is to find out the your resultant. So this over there. So let's first write down over there. Now we have to find out the resultant. So how to find out the resultant? We are having the formula. So r is equal to under root of summation of f of x square plus summation of f of y square. So substitute the value over here. Summation of f of x is 0 and summation of f of y square is 250 square. Square and square root get cancelled. So you will get the value of r is 250 Newton and it is in vertically downward direction. So without writing this formula also, you can easily able to say that the resultant is 250 Newton vertically downward because there is no force in x direction. So whatever the value of summation f of y in this problem is this value of r. Getting that? But it is not always. If any force is inclined in that case, you have to find out its x component and its y component, and then you have to add this. So thus we are able to find out the resultant 250 Newton and it is vertically, so it is vertically upward, so it is vertically upward because it is plus indicates that the force acting in a upward direction. Now next step is to find out the moment about A. They have asked us to find out the moment about point A. What is moment? Moment is nothing but the force into perpendicular distance. Now they have asked you to find out the moment about this point A. Okay, moment we have to find out this point A. Now let's begin how to take the moment. First force 250 Newton. What is the moment? Force into perpendicular distance. So here force is 250 Newton and the perpendicular distance of this force from point A is 0. As this force is itself passing through this point A, so it will not create any moment. So therefore we don't have to consider this force because it is passing through point A. Let's come toward the next force. 500 is the next force and the perpendicular distance of this force from this point A is 3 meter. So 500 into 3. 500 into 3. It will create the moment in which sense the moment is in clockwise or anti-clockwise. It creates moment in anti-clockwise sense. Our assumption is that anti-clockwise is positive. We assume the anti-clockwise is positive, so 500 into 3 plus. The next force 350. 350 into perpendicular distance 4.5 plus 3 7.5. It will create the moment in which direction? It will create the moment in clockwise sense because this force is in downward direction. As this force is in downward direction, it will create the moment in clockwise sense. Therefore, it is minus 350 into 7.5. Let's come toward the next force 150 Newton. What is the perpendicular distance? 3 plus 4.5 plus 2.5, that is 10 meter. This total distance is 10 meter. The force 150 Newton multiplied by the perpendicular distance 10. So 150 into 10, it will create the moment in anti-clockwise direction. Therefore, it is positive. So positive 150 into 10. The next force 200. 200. What is the perpendicular distance? 3 plus 4.5 plus 2.5 plus 2. It comes out to be 12. So 200 into perpendicular distance 12. 200 into 12. 200 into 12. Whether it is positive or negative, it will create the moment in anti-clockwise direction. So therefore 200 into 12. So your moment is 2775 Newton meter. So it is positive. Answer is positive. So it indicates that the moment is in anti-clockwise sense because we have assumed the direction anti-clockwise is positive and our answer is positive. So assumed direction is correct. If your answer comes out to be negative, so it indicates that this direction instead of clockwise, anti-clockwise, your moment is in a clockwise sense, because positive indicates the anti-clockwise direction and the negative indicates the clockwise direction. Here we have to write down the answer is like this: 2775 Newton meter. This is the unit of the moment, Newton meter, and this is the direction of moment. Okay, so this is very basic problem we have learned today. Now next, come towards the next problem. So in this problem, what is it? It mentioned that find the resultant in magnitude and direction for the system of forces as shown in figure, and also find its location with respect to point A. They have asked you to find out the resultant of the system of forces and its location with respect to point A, where it will be at. In first problem, they have asked you just moment. So in this problem, they have asked you to find out the resultant and its location. Once location is asked, you must have to use the Varignon's theorem. In order to find out the location of resultant, we have to use the Varignon's theorem. Okay. So this is system of forces. How many forces are there? 1, 200, 600, 750, 400, and 500. 1, 2, 3, 4, 5 forces are there. So these 5 forces are there. So first we have to find out the resultant. In order to find out the resultant, this force is inclined. We have to resolve this force into its 2 components. What are the 2 components of this force? So first component is in horizontal direction. So there is f of x. This component of this force in x direction, that is 500 cos of 30 degree, as angle is with respect to horizontal is given there for 500 cos of 30, and it is towards right, therefore positive. Another component of this force is 500 sin of 30. It is again positive because it is in upward direction. Similarly for this force is in which quadrant? It is in 3rd quadrant. Therefore its y component is negative. What is that? 600 sin of 45. It is negative. And the another component is in 3rd quadrant, again x component is also negative. So we have to resolve this force. Inclined force is given, therefore we have to resolve this force. So 600 cos of 45, it is minus. Why minus? Because it is in 3rd quadrant. Both x and y component for the force which is in 3rd quadrant, its component is also negative. So another force is there. This force 400 Newton. It is again in 3rd quadrant. So its vertical component is negative. That is 400 sin of 45. It's minus. Then this component, horizontal component, is 400 cos of 45. It is again minus because it is again in 3rd quadrant. So we have resolved all the inclined forces. Then next step is to find out the summation of f of x. What is summation of f of x? Summation of all the forces in x direction. We have to assume towards right positive and towards left negative. So here I have written the sign towards right positive. Summation of f of x, summation of all the forces in x direction. What is the first force? Let's start from this force. The component of this force in x direction 500 cos of 30. It is plus. Then second force 200 Newton. It is vertically upward. So this should not be appear in your summation of f of x equation because it is in vertically upward direction. The x component of this force is 0. Okay. Now next, this force. What is its x component? Minus 600 cos of 45. Minus 600 cos of 45. This is second force. The third force 700 Newton. It is vertically downward. So it is truly vertical. So its x component of this force is 0. So this x component will not be appear in your summation of f of x equation. Now comes toward the next force 400 Newton. It is inclined. So we have to find out its x component. What is its x component? Minus 400 cos of 45. So this is minus 400 cos of 45. So you will get the minus 274.09 Newton is summation of f of x. Similarly, we have to find out the summation of f of y. What is summation of f of y? Summation of all the forces in y direction. So what are the forces in y direction? Okay, let's say this force 500 Newton. Its component in y direction 500 sin of 30. So this is 500 sine of 30. Why it is positive? Because it is vertically upward direction. Then next force after that, this is 200 Newton. It is vertically upward. So it is positive or negative? Yes, it is positive because it is vertically upward. So this is plus 200. This is second force. Now third one force, this third force. This 600 Newton makes an angle of 45 degree with respect to horizontal is given. Therefore, we have to find out its vertical component. What is its vertical component? 600 sine of 45. It is in third quadrant. Therefore, it is in minus. So it is going in a downward direction of its y component. So it is minus 600 cos, instead of cos here should be sine. Okay, sine 45 cos of 45 both are same. So sine of 45 minus 600 sine of 45. Then come towards the next force. What is the next force? 700. It is vertically in downward direction. Therefore plus or minus vertical downward. Yes, it is minus. So minus 700. The next force minus 700. Then next, this is 400 Newton. It is again in third quadrant. So its y component in y direction, in vertically downward direction. Its y component is 400 sine of 45. 400 sine of 45. It is minus because it is in downward direction. So after solving this, we will get the value of summation f of 1 minus 957.106. So R is equal to, we will get by using the formula summation of f of x square plus summation of f of y square in square root. So from that we will get the value of R, that is 995.57 Newton, and it is in third quadrant. Why it is in third quadrant? Because its y component is negative and x component is negative. In order to find out its direction, we are having the formula theta is equal to tan inverse of summation of f of y upon summation of f of x. So from that, substitute this value and you have to find out this value of theta in radian. So you have to solve by your own in order to find out its direction theta, and it is in which quadrant? X negative, y negative. It is in third quadrant. So location of this resultant is third quadrant. So you have to show like this. This is your resultant in third quadrant, and theta, this value of theta here you have to show. This is R. Okay, now R is known to us. What is the value of R? 995.57 Newton. Now to find out the position of R with respect to point A, therefore we have to apply the Varigno's theorem. So in order to apply the Varigno's theorem, we have to take the moment about point A of all the forces, which is equal to the moment of resultant about the same point. So instead of here, I will write the equation of moment for you on board. Let's start by one force. So I will write down the equation of moment about point A of this system of forces. Okay, let's begin with this force first. 700 Newton. 700 Newton force is passing through point A, so it will not create any moment because perpendicular distance of this force from point A is 0. As this force is itself passing through point A, so it will not create any moment about point A. Now the next, the second force. What is the second force? This is 400 Newton. So we have to resolve this force into its two components. So out of that two component, this component, that is horizontal component, which is passing through point A. So therefore perpendicular distance of x component of 400 Newton force will create the zero moment, or the moment created by the x component of 400 Newton force is zero, because perpendicular distance of this force from point A is 0. Or another word, we can say that the force itself passing through point A, so it will not create any moment. Now the next force is 400 sine of 45. This 400 sine of 45 into perpendicular distance is this one. What is this perpendicular distance? Is 0.25. 0.25. This is moment, force into perpendicular distance. Now this will create the moment in which direction? Create the moment in clockwise sense. But our assumption is clockwise is minus. Then next, this force is over. Now come towards this force. 500. So it's now instead of the same time we have to consider its two component. What is the first component? 500 cos of 30. Second component 500 cos of 30 multiplied by perpendicular distance. So in order to find out its perpendicular distance, can I show this force here? Is it possible to show same force over here? Yes, it is possible by using the principle of transmissibility. We can show the force anywhere on its line of action. So from that we can able to find out this distance. What is this distance? Is 0.25. 0.25. Now force into perpendicular distance. Next step is to find out its direction of movement. So here this is force, and if we try to move this part in clockwise sense, it will create the moment in clockwise sense. Therefore clockwise is minus. Okay. Now the second component is 500. I will write for you here. 500 sine of 45. Again perpendicular distance. 500 sine of 45. I will show here by principle of transmissibility. This is the perpendicular distance. 0.25 plus 0.25. So what is the distance? 0.5. So 500 sine of 45 into 0.5. Now you tell me where you can create clockwise or anti-clockwise movement. Okay. So you can try to rotate this element in the direction of force. So it will create the moment in anti-clockwise sense. म्हणजेच घड्याळाच्या काट्याच्या विरुद्ध दिशेने. So it will create the moment in anti-clockwise sense. So it is positive. So this force is again over. Now come towards this force 200 Newton. We create 200 into perpendicular distance is again 0.5. Force या force आणि ह्या point A मध्ये perpendicular distance किती आहे 0.5. It will again create a moment anti-clockwise sense. So it is positive. Okay. Then come towards this force 600 Newton. It's one component. Sine component is passing through point A. It will not create any moment. So the only this component will create the moment. What is that component? 600 cos of 45. Perpendicular distance this one is 0.5. Okay. Now you tell me whether it is create the movement in clockwise or anti-clockwise sense. Okay. Now try to rotate this. It will create the movement in anti-clockwise. So therefore it is positive. So this is the summation of moment about point A. So you will get the answer. The answer after solving this, you will get the answer 258. 258.68 Meter. So this is the moment of all the forces about point A. Now moment about A is known to us. Now by applying the variance theorem. What is the variance theorem? Summation of moment of all the forces about any point is equal to moment of resultant about that point. So R is the resultant, X is the perpendicular distance of resultant from point A here. So what is the moment about A? We will get the moment 258.68 is equal to R. What is the value of R? 995.57. 995.57 into X, where X is the perpendicular distance of resultant from point A. So you will get the value of X after solving this 258.68 divided by 995.57. So that comes out with 0.259 meter. So this is your answer. So how to show this force? So for you, I will draw the diagram. So location of this. So from in this figure, I will show the resultant. Let's say this is your rectangle A, B, C, D, and you can show the resultant anywhere is in third quadrant because X and Y both are negative. So you can show your resultant in third quadrant like this anywhere. This is your resultant R, and this distance we have find out. This is the x distance, that is perpendicular distance. So that is the location of resultant from point A. This is the distance x, that is 0.259, and this is your resultant r. And this angle, that is, I think, if after solving this, you will get the angle 74 point something. It is in third quadrant. Okay. So resultant is known to us, its location is known to us. So we have able to solve this problem. Okay. So today we have learned how to find out the moment, how to find out the resultant of parallel force system, as well as how to find out its location of resultant. Location of resultant is find out by using the Varignon's theorem. So you must have to take care of sign convention while writing the equation of summation f of y, summation of f of x, and the equation of moment, as well as by write down the equation of Varignon's theorem. So these two problems we have today solved. So thank you very much.